variable is just there, and it might influence your results. I always use the example of growing a plant. So say we want to see if we have like the best fertilizer. So we want to see how well our plant grows. Aren't there a lot of lurking variables? Aren't there a lot more variables that affect how a plant grows, right? Like soil, sun, water. And we have to take those into account and keep them stabilized so that that's not the reason why our plant's growing so great. It's the fertilizer that we can tell that's making the difference. And then variability of data is just the fact that data is real, so it's going to vary, right? Data is real. ... So it varies. What do I mean by that? Go back to my definition of data. The very first thing I listed was height. You guys are all real people, all of different heights, right? What kind of world would we be if we're all the exact same height? So that's what you're going to find. And even you singularly, whatever data you collect throughout the semester, you're going to notice day to day, it's not consistent. Some of you guys are really consistent actually, but most of the time it's not, right? It's real life things. And so that's why I always ask you, if you forget a day, don't make it up. Just skip that day, okay? Because you want it to be more accurate than false, okay? All right, so let's get into objective 2, explaining the processes. Nothing too exciting here, but there's some definitions that we definitely have to feel comfortable with. One is a population, and a population is what you think. It's just everybody, right? The population of Lewis and Clark is everybody that goes to Lewis and Clark. So whenever we're studying something, we have to identify the population. It could be human or it could be otherwise. We might be studying, again, the cars in the parking lot, right? That would be our entire population. So one thing about the population, guys, is a lot of times when you're working on it in your homework, it's not really specified. You kind of have to just use inferences, right? So if I want to know the average age of college students, then the implied population is all college students. Like that word all there, it's everybody. The second thing is exactly what you think, an individual. What is it? Just one single person or object that's from the population. But you'll quickly find that studying one individual is not very helpful. Studying the whole population is nearly impossible, so what do? We take a sample, okay? So a sample is going to be used a lot throughout the semester. It is a subset of the population. Does everybody know what subset means? Like a small chunk of it, right? So if you go out to, does anybody go to Costco or Sam's when they're serving you the food, right? They're giving you samples. They're not giving you the whole cheesecake. They're just giving you a sample, a bit of the cheesecake. So that's what you're going to find. Ideally, we would like to study the entire population. Time, money, effort, we don't have it, right? So the next best thing is to take a sample. Individual, we don't get a whole lot by asking one person. So let's see if we can do it with this example. A study was published in 1990 to attempt to estimate the proportion of Florida residents who are willing to spend more money of their tax dollars to help protect their beaches from environmental disasters, okay? 2,600 Florida residents were surveyed. So reading that statement, can we figure out what the population is that we're studying, and can we figure out what the sample is? What would be the population that we're studying? All Florida residents, absolutely. Do you think we can get a hold of every Florida resident? No. So what do? We take a sample and we send that survey to just a sample. Who's the sample that we send it to? The 2,600 residents that got the survey. Absolutely. So 2,600 Florida residents surveyed. So always just think population is holistic, it's everyone, and the sample is smaller, it's the chunk. Right? And this is kind of how my math lab will be. It's not like obvious what the population is. The sample, you'll always see surveyed or asked or something like, there'll be some verb by the sample, okay? So notice it's 2,600 Floridas were surveyed. That usually is pointing to the sample. The population, we kind of just have to infer it. All right, let's look at the next thing. A statistic is going to be what we use to call any kind of numerical summary of a sample. So I tell you guys all have probably done a small chunk of stats, mean, median, and mode. Have we all heard of those before, right? So those are numerical summaries. are averages, right? So depending on whether you are using numbers from a sample or a population, they're actually called two different things, which is frustrating because same exact formula, it's telling you the same exact thing, but who are you getting that data from? So what I want to make note of is statistic starts with an S, and sample starts with an S, okay? So if you find a mean from a sample of people, that mean is called a statistic. But if you find a mean from a population of people, it's called something different, and you'll see in a second what that's called. All right, so there's two different types of statistics. The first one is descriptive, and the root word in descriptive is what? What's the root word in descriptive? Describe, you got it. So descriptive statistics are going to tell you something about those stats that you found, okay? So after you collect all your data, your statistics are going to either be organizing or summarizing, and they're going to be telling you something about what you found, whether that's numerical, like a mean, or with a table. Here's a table of how many people prefer apples over oranges over bananas, okay? Or some kind of graph, all right? So if you're describing it with a number or a picture, you have a descriptive statistic, all right? Go ahead and flip the page over to the top of page 2. The second part of statistics is called inferential statistics. What's the root word in inferential? Infer, or inference, exactly. And that's a word that we all use, but it's really hard to define. How would you describe infer? Yeah, you're assuming, like, it's like an educated assume, right? Like, you kind of have an idea what's going on, and so you make some kind of conclusion based on that. Are you 100% sure it's right? No, but you're hoping that it is. And that's exactly what inferential statistics is, okay? We're going to get all this data and all this descriptive data, and then we're going to look at it and be like, okay, now that we know this, what does it mean? All right? So that's exactly what the definition says. It says, what we do is we take the results from the sample and we extend it to the population, right? So if I want to know the average age of college students, I might just start with Lewis and Clark students and find that the average age is 23, okay? So then that's just my sample, right? But then I can apply it to the population saying, if I took enough sample size and I did a good job taking it, I can infer that maybe all college students, the average age is 23, okay? So we really don't start doing the inferring until about chapter 9 or 10, all right? So it takes what we have from the sample and it makes sense for the population. All right, last one here before we try our best at some vocab is a parameter is a numerical summary of a population. If you flip, and you don't have to flip, but I will. A statistic is a numerical summary of a sample. It's basically the exact same definition, but it was what I was telling you. Depending on whether you are asking a sample or a population, it's called something different, okay? So if we find a mean from a population, it's actually called a parameter. And notice that parameter and population both start with P's, okay? So that's what they're going to have us try here with this next example. They're going to give us 3 scenarios, and there's going to be some key words in those scenarios that are going to let us know that we're either drawing from a population or a sample. And if we know it's a population, we know that numerical summary is called a parameter. But if we're drawing from a sample, that numerical summary would be called a statistic, okay? So it's kind of weird. We don't go right to parameter or statistic. We need to go, is it a population or a sample, all right? So let's look at A. Ty Cobb is one of the MLB's greatest hitters of all time with a career batting average of 0.366. Is that value, that average of 0.366, a parameter or a statistic? You want to say statistic. Why? Because every sporting thing is always called a stat, right? But there's a couple key words in there. All time and his career batting average. Was it just one season? No. Was it just one game? No. It's every at-bat he ever had, right? So that's actually his population of hitting. So even though sports we think stats, if it's an all-time career stat, it's actually called a parameter, okay? So what we're going to do So we're going to underline career and say that's technically the population of his batting. So it's a parameter. Now, if I said Ty Cobb's batting average for, he doesn't even play now, whatever season he was playing, 2001 season, that would be a stat, right? Because it's just one season out of the many he played, okay? So it's a sample. Let's look at B. Interviews of 100 adults found that 44% could state the minimum age required for the office of U.S. President. Is that a parameter or a statistic? Statistic. And again, with stats, they always kind of have the words interviewed, survey. You know they're just kind of asking a few people, not everyone, right? Does anybody know how old what's the minimum age to be president? 35. It is 35. Good job. Woohoo. I ask that every year, and there's always at least one person in there that knows it. So the fact that we're interviewing only 100, we know that's just a sample, right? And if it's just a sample, that 44% is considered a stat. C, in a survey of 1,300 high school students, 32% reported that someone had bullied them at the school. Parameter or statistic? Statistic. And again, in a survey, right? And unless they said of all high schoolers in the U.S., but we know there's way more than 13 high schoolers in the U.S., right? That might just be one high school. How big was Alton High?
Too big.
Too big. Was it in the thousands, probably? Okay, so we know that that's just a sample of all high schoolers in the U.S. or whatever, right? So again, that word survey, interview, it always kind of hints to sampling. And we know there's more than 1,300 high schoolers, so that makes that 32% a statistic. All right, so let's go ahead and fill out these. We'll go pretty quickly because we're going to get a little bit more in depth with them. This just to me is like if you ever did a science fair project back in junior high, these are the steps that you did, right? So when you want to do stats, the first thing we have to come up with, it'd be good if I was looking at the answers, right, is identify the research objective. Decide what you want to study. That's what you guys have to do on that yellow sheet, right? What are you going to study this whole semester? Now, to know what we're going to study, we need data. So what we're going to do is we're going to collect data. And that's what you guys are going to do the majority of the semester, right? Like, not a whole lot of work other than just remembering to write down that daily thing that you're looking at, all right? So all semester long, you collected data on a certain research objective. At the end of the semester, around Thanksgiving, beginning of December, you guys are going to describe that data. What does that mean? That means you're going to have a variety of tools to do it. You're going to be able to come up with an average, some quartiles, what else am I going to have? Standard deviation. You're going to be able to make a chart with it, all kinds of stuff, okay? So once you have your data, you're going to describe what you found. But what's the whole point? And again, it's my goal as your stats teacher this semester. The point is to get something from it. I'm not just doing it to give you busy work. I want you to draw some kind of conclusion from it, right? So number 4, guys, is perform inferences. Whatever that may be, okay? So if you were collecting on how many ounces of water you drink a day, and you find that you drink over 70 ounces a day, that's awesome. Your inference would be, I'm drinking plenty of water, right? But if you're collecting data on how many Snapchats you send a day, and you find that you're sending 100 Snapchats a day, you might say, ooh, that's not so okay. I'm sending too many Snapchats, whatever it may be, okay? So, and that's how we do it, whatever research objective. Whether you're going to be a nurse, a civil engineer, there's some kind of thing you need to know, collect data, and find out what you know, okay? So what I'm going to do is I'm going to get the book here, so page 12, number 48. And you guys will just read this with me. In this book, what's kind of neat, again, I say it's, you guys don't get to pick what we're studying, but these, if they are, you'll notice like here, it's sourced. If it's sourced, it was a real study. So even though you guys don't get to pick it, and it's maybe not the most like interesting to you, it's real stuff. It's not made up, okay? So we're gonna do number 48 here. It starts down here and then it goes to the top, and I'll do that with you. It says a cure for the common wart. A study conducted by researchers was designed to determine if application of duct tape was as effective as cryotherapy, which is liquid nitrogen. Has anybody had a wart frozen off? Okay, so they use, like, liquid nitrogen is so cold it basically freezes your wart off, that kind of thing. You get it done at the dermatologist, okay? So someone out there said, I think duct tape can do the same thing, right? So what happens, let's go up here. The researchers randomly divided, it's kind of hard, sorry, randomly divided 51 patients into two groups. 26 patients were in group 1. They had their warts treated by applying duct tape to their wart for 6.5 days, and then removing the tape for just 12 hours, and that cycle repeated for a maximum of 2 months. The other 25 patients were in group 2, and they had their warts treated at the dermatologist with liquid nitrogen for a maximum of 6 treatments. Once the treatments were complete, it was determined that 85% of patients in group 1, the duct tape people, and 60% of patients in group 2, the cryotherapy, had complete resolution of their warts. The researchers concluded that duct tape is significantly more effective and way cheaper. Do you want to wear duct tape on you is the question, though, okay? So let's see, and if we need to go back and forth, we can, but I think you guys have enough information to help me fill in these questions. So the first question is, what was our research objective? What did we care about? What did we want to find out? See if the duct tape would remove warts. Yes, so like duct tape versus cryotherapy, which one was the best for removing warts? You guys agree with that? Okay. So was duct tape as effective at removing warts as, I have a really hard time saying it, cryotherapy? And it's interesting because liquid nitrogen is so cold, but it technically burns you, right? It literally burns the wart off. All right, so 2 questions after that. What was it, and I want to put in like an adjective, what was the applied or implied population? Patients. Not just the patients. Who are we helping once we make this discovery? Everyone. Everyone with warts, right? So like the patients would be the sample, right? It's the 51 people that we were studying. But what we discover that duct tape's better, that's going to help all of us who ever had a wart, okay? So this is what I'm talking about. The population's not flat out told to you. You kind of just have to infer it, right? So the population was everyone with warts. And from that group of people with warts, they were able to pick 51 of them, okay? That's our sample, okay? The 51 patients with warts. Sometimes I find it easier to come up with the sample, and so I work backwards. So I know if the sample is 51 patients with warts, you just ask yourself, well, where did they come from? They came from a group of everyone that had warts, right? We randomly pick people. And so kind of sometimes working backwards helps you. All right, so this is where I might have to refer back to the page because our memory, you guys might actually have it memorized. The descriptive stats is anything that's numerical, a table, a graph, or a chart. Well, did you see graphs, charts, or tables? No. They gave us 2 percentages, okay? Those percentages were our descriptive statistics. Does anybody remember one of the 2 even?
80%, 60%.
85 and 60. You guys are good. Okay, so 85% from group 1 and 60% from group 2 had resolution of warts. Is everyone okay that resolution means it cleared up? Okay, it resolved itself. And just from that information, you can draw your own conclusion, but they flat out told you in that last sentence what was better. The duct tape. So the conclusion was that duct tape was more effective with removing warts. But don't you guys, couldn't you get that from out without them even ever saying it? Like just looking at those two numbers, the 85 versus 60? I would say group 1 was a lot better. What did group 1 use? The duct tape, okay? The conclusion was that duct tape was more effective. And again, I kind of took it off real quick, but it was sourced. This was a true study. So again, way cheaper, but and you literally have duct tape on whatever body part for 6.5 hours or 6.5 days straight. So I don't know if you want to deal with that. Maybe if it's on the bottom of your foot or something like that. Are there any questions with coming up with the different research methods? Are we okay? So objective 3, guys, is what I wanted to kind of get to. This is where we have a lot of vocab thrown at us, okay? So we want to make sure we are comfortable with it, we can distinguish between the two, and so forth. I'm going to try my best to kind of hint why one is the one. All right, so the first one is just variable. What is a variable? It is the characteristics of the individuals from which we're studying, okay? So any of the data can be considered variables, all right? So we have 2 types. We have qualitative. Root word of qualitative is quality, right? So let's write that off to the side. Because when you look at the definition of qualitative variable, it classifies individuals based on some kind of characteristic or attribute. It's not numerical, right? It's some kind of quality that that person or object holds, all right? So some examples of this would be eye color. Do you guys agree that we could collect data and organize all of our different eye colors, right? Is it a numerical measurement, though? No. Another one is religion. Whether you're an atheist, Catholic, Christian, Methodist, whatever it may be, we could group each other. And again, it's not numerical, and so it'd be qualitative. Now, I throw this one in not to trick you, but to make you think a little bit. Zip codes. And you might say, hold up, Molly, you just said that qualitative variables are not numerical. Well, even though zip codes are made of numbers, does it make sense to do math with them? Like, should we start averaging zip codes or adding and subtracting zip codes? What would that even mean, right? But we could do 90210, 63055, 62294, right? We could organize and group that way. But doing math on them doesn't make sense. Another example would be like phone numbers. Those are numerical, but does it make sense to start averaging or subtracting phone numbers? No. So there's a handful of things that are numbers, but they're qualitative variables. All right, go ahead and flip it to the top of page 3. Quantitative, the root word is what? Quantity, right? And so these are going to be the numerical measurements that make sense. It makes sense to add them or average them or whatever it may be. And even though both are basically infinite, I feel like it's easier for us, I don't know why, to come up with numerical measurements. But qualitative and quantity, like everything, all the variables could be infinite. So what do I have here is weight. We can classify in certain ranges of weight. But it also makes sense to start averaging weights or subtracting weights to see the difference in weights or whatever it may be. So math makes sense. Hours on Netflix. Again, it's a numerical measurement, and we can start averaging or comparing. I think, what's my last one on here I have? Number of meals a day. I feel like these diets are all the fads. So somebody might be doing intermittent fasting and only eating 1 meal, where I am eating like 8, right? So we can either average or find the difference, and all those values make sense. All right, so I stole this a long time ago, and I feel like I need to edit it because it's not too exciting. But here is a small sample of somebody's class roster, okay? So we have names on the left. We have their intended major right next to it. But in the specific class, it's based on, like, maybe say 500 points or something like that. So we have their total points and what those points give them as a letter grade. All right? So what or who are the individuals in this sample?
Students.
The students, you got it, right? The students. So, and again, it would be a sample, so what would be the, it's not a question on here, but what would be the implied population? The school, right? Like where they're coming from? All right, what are some of the variables? And there's a lot here, not just the obvious labeled ones, right? So what are some of the variables of these students? Majors. What else? Points. What else? Grade. What else? And I heard outside factors, basically anything else we wanted to name. Gender, weight, eye color, right? So even though this data set is giving you some specific variables to look at, there's many, many more, because look at our individuals we're looking at, the students, right? There's anything from the students that we could study or collect could be a variable, right? Let me put like height on there. I just want to add one extra one, just so you know it can come from outside this list. What'd you say? Yeah, I think I used height for the specific example of like data or something collecting. All right, so of these, what did I give us? 5 different variables. Which of them are qualitative? Describe a quality that's not numerical.
Major.
What do we have? Major. What else? Name. What else? Letter grade. And that's kind of tricky, but is there any numbers specifically with the letter grades A, B, C? Now, there's some that correspond to us to get us there, right? Yeah. But on your grade or report card, you just get that A or you just get that B. So we'll put grade, but then what are we going to turn around and put for the first thing in quantitative? The points that go to that grade, okay? Do you guys see the difference there? So they're both a measurement of how well they're doing in the class, but one's numerical, we can average it. We can say the difference between two students. But A, B, and C, unless we give it points, for example, grade point average, they have to assign 4 points to A, 3 points to B, right? So A, B, and C themselves are not quantitative. So let's put points, and then why did I write height? So you know there's multiple, right, quantitative ones. So heights would be their weight, their age, exactly, yes. So, and like I said, for some reason I feel like we can always come up with way more quantitative than qualitative, even though both are infinite. All right, so when we're doing this, I'm going to pause this for a second because it only lets me record 30 minutes at a time.